Okay, now we have come to the last topic of core Java, threads. Threads is actually one of the most important topics in Java, and probably it's one of the most confusing topics as well. So here in this session, we are going to try and see what threads are all about. Okay. So the basic definition of thread is a thread is a lightweight process, and it is used to provide the ability to perform multiple things at the same time. So the second point is what we probably need to focus on more about, right? And what it really means. Okay. So let's just go back to our previous topics where we discussed about stacks and heaps. Right? So we told that a stack is nothing but a memory structure where you store the methods and the method variables, right? And basically it stores the execution stack of your methods, right? So let's say for example I uh, created a class and I executed that class. When I run the class, the main method would be run, right? And let's say that you don't have this, just forget this thread dot start for the time being. Okay, and let's say that my main method calls method 1, so I have method 1 on top of main method on the stack, and if method 1 calls method 2, I'll have method 2 on top of method 1 on the stack, right? So as I keep calling methods in this flow, all the methods keep adding up onto the stack, right? So it executes a push operation which pushes the method on top of the existing methods, right? And similarly, once method 2 is done processing, it comes back to method 1, and once method 1 is done with the processing, the control comes back to main method, and then it exits the stack, right? So let's take an example where in between you call a thread. What happens? So thread is nothing but basically it's a class again. So we'll discuss more about what's the structure and how do you write a thread, right? For now, you just keep in mind that thread is nothing but a class, but it is a special class which has got some special features, right? So when you call a thread from your main method or any method from the current execution stack, when you call a thread, what happens is it actually creates a new stack of execution for you for that thread, right? And all that processing is done in the new stack of execution. So here what is happening is at the same time I have my stack of execution running, and I have the other stack of execution as well, which is nothing but the stack created for the thread, right? So basically there are two threads running at the same point of time, right? So this is what the concept of threads is all about. It allows us to perform multiple things at the same time. So whatever is going on here will take place, and at the same time whatever is going on here will also be executed. So at the same time I'm having the ability to perform multiple things. So this is the basic concept of threads. Okay, so we'll look into more details in the later slides. So I just told you that thread is nothing but a class, right? And it is a special class which has got some special features. So how do you put in that special features? So what do you need to do to make your class a special class and treat it as a thread? So there are two ways you can create a thread. So you write your class and extend the thread class. Okay, so thread is a class and you need to extend this class called thread if you want to treat your particular class as a thread, right? And alternatively what you can do is you can implement the runnable interface. So these are the one of the two things you can do to treat your class as a thread, either extend the thread class or implement the runnable interface. So in the next slide we'll see how you do both of these. Okay, so now we just discussed that using threads you can perform multiple things at the same time. So let's just take an example where you would have the need to do such kind of processing, performing multiple things at the same time. Okay, so let's say, for example, that you have a website, right? And the user logs on to your website and or logs onto the application and performs various activities, right? He keeps adding some records, deleting certain records, updating them. So basically maintenance activities, right? And the user also has ability to generate reports, various kinds of reports, right, from the application. So, so this generating report part is basically it takes time. So let's, because it has to do some complex querying and give you thousands or millions of records back. So it's going to take time. So let's say that the report generation part takes me about 10 or 15 minutes, right? So once I click on generate report, it at least takes 10 or 15 minutes for me to get back the report. So in a usual scenario, what would have happened is the user logs on and he verifies his credentials, so the user validation takes place. So once the user validation is completed, the user goes to a report screen and he tries to generate a report, right? And the report is being generated, which takes about 10 to 15 minutes. And in this period of time, the user is simply sitting idle over there, right? He doesn't have any work because he cannot do anything because the application is locked down and the server is processing something and the user is waiting for the result. So only once he gets back the result, he can do any other things on the application, right? So once the report is processed, after 10 or 15 minutes, the user again does the regular maintenance work which he usually does, right? So in this scenario, this 10 minutes where the report is processing, the user is simply sitting idle without any work, right? So he has nothing to do with the processing of the report. He doesn't have any inputs to give, or everything he has given it, but there's nothing he needs to do, but still he's waiting there 10 or 15 minutes for the report to get generated, whereas in that time he could have done a lot of other things, right? So when you talk about threads, when threads comes into the picture, what happens is the user logs in, the user validation takes place, and when the user tries to generate a report, a new thread is kicked off, right? And the thread basically does the report processing, and at the same time the user can perform the regular maintenance work using the second thread, I mean the original thread which the user was working on. So if you see here, let's say that the t1.start actually kicks off the thread which does the report processing. So once the thread that processes the report is kicked off, you have a new stack of execution which only does the work of processing the report, and on the main stack you can simply perform your maintenance activities. So at the same time you can do your maintenance activities, and in the background the report is being processed as well, right? So all this, you don't have any interaction with the system, right? So you can simply leave it to the system to do the processing, and the system will get back to you once the processing is done. It gives you a some Excel file or PDF file with the report, or probably it can save that report to some predefined location on the server or the machine, some shared machine, right? So this is one of the advantages or one of the scenarios where you can use the. Okay, so now we just talk that there are two ways you can treat your class as a thread, either by extending the thread class or by implementing the runnable interface. So in either of these two ways you can treat your simple class as a special thread class and get the thread features and abilities and behavior in your class, right? So when you extend the thread class, you simply say your class that extends the thread class, and To implement the runnable interface, you simply say your class implements runnable interface, and in both the cases you override the public void run method, which doesn't take any arguments. So basically, whenever you call your thread, the public void run method will be invoked, right? And that is the starting point for all your business logic which you put in your threads. So all the other methods you call it from your public void run method. So this is like a main method for your thread, right? And how do you call your thread? You don't simply call the run method, but you make a call to t1.start, right? So when you say t1.start, your run method is being invoked. So basically, start is not a real method in your thread class which you write, but the actual method is the run method. But when you try to invoke your thread class, you say t1.start, right? So this is because your thread is a special class, right? It's not a normal object. It's a special object, right? And if you would have said t1.run, the system, the JVM wouldn't consider your thread as a special object. And if you say t1.run, it will not create a new thread of execution, right? So that keep in mind. Only when you say t1.start, it treats your class as a special thread class, thread object, and invokes a new stack of execution and does the processing, right? It appears as that you're having multi-threaded feature there, right? But if you say t1.run, this will simply call your run method in your thread class but not treat this as a thread and does not start a new thread of execution. In fact, it will simply continue in the same stack as if it was a normal object. So even though you have the thread features and abilities, you need to use that in the right way to make use of it, right? And when you use the runnable interface to invoke the thread, you need to create an instance of your class and then pass it as an argument to the thread class and then say t1.start. So we have these two methods to create a thread. What do you want to use? Do you want to use the extends thread class or implements runnable interface? And what are the advantages of using extends or interface? So basically we know that Java doesn't support multiple inheritance. So if you say extends thread, you will not have the ability to extend any other classes, any other super classes, right? If you want to extend any other class into this class, you won't be able to do that if you say extends thread. Whereas when you say implements runnable, you have an option to extend some other class if you want to. So that's one of the advantages of using implements runnable than extending thread, right? And other than this, even if you think about it logically, when you say extend thread, you're trying to say that your class is nothing but a special version of the thread class, right? And when you say implements runnable, you're trying to say that your class has certain behavior belonging to the thread, right? So your class is truly not a special version of a thread class, but it has the features and behavior of a thread. So I suggest you go with the implements runnable interface always and not extends thread, right? Okay, so let's have a look at the thread lifecycle now. Okay. So earlier we've talked that using threads you can perform two or more activities at the same time, right? So does it really happen? Can you actually perform two things at the same time? Actually not. You can basically correlate this to yourself. Can you at a single particular point of time perform two activities? No, right? Unless certain things which are already registered in your subconscious mind, you cannot actively work on two different things at the same time. So let's take an example where you are working on a project and at the end of every week your defects are being discussed, right? And at the end of week, let's say that you've been assigned two defects and at the end of week the project manager is going to ask you for the status of the defects you have been working on. And you say that you have worked on 2 defects and you have successfully fixed 2 defects in that week, right? So your project manager is basically going to get an impression that you have worked on both the defects throughout the week, right? But that's not true, right? So let's say that you started off with defect 1 and you had some issues and you've asked questions to the concerned people and you're waiting on some answers on defect 1. So you went back and you started working and looking into defect 2 and started working on that. And in between again, the person comes back to you with the answers you asked, the questions you asked for. So you start working on defect 1 again. And similarly, you keep switching between defect 1 and defect 2 based on your availability and whether you have everything to work on that particular defect or not, right? So even though at any particular point of time you have not worked on both the defects, you keep switching between defect 1 and defect 2, at the end of the week, the only impression someone gets is that you have been working on both the defects throughout the week, right? So similarly, when you have 2 different threads, no 2 threads are running at the same time, right? So at a particular time, there is only one thread which is actively running, right? And the other threads are simply waiting to be run. And the JVM basically employs a number of different complex algorithms to determine how do you basically manage the time between between the different threads, right? So let's say that in the report example, I have a report and maintenance work, right? So let's say that just for example that it allocates 2 seconds for the report generation and then switches back to the maintenance task and allocates 1 second, then again switches back to report, allocates 1 second, switches back. So it basically switches back and forth between these 2 threads, and at end of certain point of time, you get an impression that it has been working on both the threads at the same time, but in reality it is not. There is only one thread being worked on at a particular time, right? So let's just see what the different states are in the life cycle of a thread and what it really means. So in the beginning we have the start state. So when your thread is ready but not yet started, it is in the start state. Okay. And let's say that you started your thread, but your thread has not really started running because there might be some other threads already in the running state. So your thread goes into the runnable state. So when your thread is in the runnable state, it means that your thread is ready to run, but it is not run yet. And when your thread is in the running state, your thread is actually being executed. So it means your run method is being executed right now. Blocked. When your thread is in block state, it means that your thread is waiting on some IO operation to complete, or it's waiting on some resource which it needs to get hold of, right? So it's not ready to run, but it is waiting on something to complete. So once it gets whatever it requires to run, it goes to the runnable state. But when it is in block state, it needs something to complete to be able to run. So we can relate this to a situation where you have posted some questions to the concerned people to work further on defect 1, but you don't have everything ready to work on defect 1. So once you post those questions out, you go into the block state for defect 1, right? And as soon as you get the answers, now you're ready to again start working on defect 1. So you go back to the runnable state, right? And when your thread processing is completed, it goes to the end state. So let's take an example where I have 2 threads, T1 and T2, okay? And let's see how they traverse between these lifecycle methods of the thread. So I start both the threads at the same time. I start T1 and T2. So basically they go into the runnable state. So as soon as I start my thread, it doesn't really go into the running state because there might be some threads already in the running state and you're never sure. So the first thing it does is it goes into the runnable state. And now the thread scheduler is going to see that there are no threads actively running right now. So it takes T1 and it puts it into the running state. So basically it calls the run method on T1, and the T1 run method is being executed right now when T1 is in running state. So let's say at some point of time after being run for some 20 seconds or so, it has requested for some IO operation and it's waiting on some response, right? So now thread T1 should be idle because it's waiting on some IO operation, and I don't want thread T1 to be waiting. So T1 will go into the block state because it's waiting on something to complete and it's not ready to run right now, right? So we need to uh, make our resources work very efficiently, basically the time, right? So we don't want to waste any time here, and we want to efficiently use whatever amount of time we have out there. So if T1 is waiting for something, even though it's in running state, just put it into the block state, right? And don't waste any time there, so that T2 can go forward and execute and go into the running state. So now since T1 is waiting, it goes into the block state and T2 comes into the running state and T2's run method is being executed, right? Let's say meanwhile T1 is again ready to be executed. So does it go back to the running state directly? No, it has to go to the runnable state again, right? So T2 is now again in runnable state, ready to be run, and T1 I'm sorry is run in the runnable state, whereas T2 is in the running state. And let's say that after some time T2 is done with all its processing, so it simply goes back to end, and ultimately T1 goes to the running state, does the processing, and it goes to the end. So basically this is the life cycle of thread and how threads traverse between different states in the life cycle, right? Okay, now let's see what the different methods of a thread are. Basically these are the most important methods which are often used. So the first two methods, start and run, we've already talked about these two methods, so we won't be discussing these methods here, right? So next method is sleep. So if you have a look, the sleep and yield methods are static methods. So basically these methods are invoked on the thread class. So whenever you call sleep or yield, they act on the current active thread which is actually running right now. So when you call sleep on the thread class, you pass in parameter to that, and the parameter is nothing but a long, which is nothing but a time. So time in milliseconds. So if you say that I want the current thread to go to sleep for 1 minute, you call the sleep method on the thread class, right? And when you call the thread method on the when you call the sleep method on the thread class, the current thread which is actively running right now in the running state, it is taken out of the running state and it goes to sleep for 1 minute. So it is not even in the runnable state, but it goes to the block state because it's right now in sleep mode and it is not ready to run at all. And after 1 minute is completed, it goes back to the runnable state where it is ready to run again, right? And when you call yield similarly on the thread class, the currently active thread which is actually running in the running method right now goes back to the runnable state, okay? And there might be a number of other threads which are in the runnable state which is ready to run. So one of those threads might come back to the running state again once your current thread is gone to the runnable state. So basically these two methods will take the current active thread out of the running state, right? But when you call sleep method, you can guarantee that your thread will not come back to the your thread will not come back to the running state for that amount of time. But when you call the yield method, you don't have a guarantee that your thread won't come back again into the running state, right? Because even though it goes back to the runnable state, based on the priorities, your thread might again come back to the running state again. right? So there's no guarantee in yield, but there is a guarantee in sleep. Next method is join. So basically, let's say that we have two threads, thread A and thread B, right? And you have some kind of preconditions there where you want thread A to complete, or basically you want thread A to start only when thread B is complete. So let's say that to process thread A, there is something that needs to be complete, needs to be ready, which is done in thread A, right? So B can only start when thread A is completed. So if you have some such kind of relationships between threads, you can use join always. So when you say B dot A, it ensures you that only when A is completed, your thread B will start its process. So until then, B will not start its processing. Next method is set priority method, and it takes an integer, and this integer can be between 1 and 10. Okay, so basically when you call set priority, it sets a priority for your method. So every thread has got a priority, and you have the static variables already defined: min priority with 1, norm priority with 5, and max priority with 5 with 10, with a value of 10. So when there are, let's say that there are three uh, threads in the runnable state, one with priority 1, the other with priority 5, and the third with priority 10. So the thread which has got the highest priority will be moved into the running state and it's executed, right? So based on the priority of the thread, your thread will go into the running state, right? So if you do not give any priority to the threads while creating the threads, or you do not explicitly set the priority for a thread, the default priority would be the norm priority for all the threads, that is 5, right? So these are the methods which are inherited from the thread class. There are certain set of other methods which are inherited from the object class, and they are wait, notify, and notify all. So this will be used mostly when you're working with synchronization, which we will shortly see now. And so basically when you have some shared resources and you have synchronized methods, you can basically use wait and notify to perform inter-threads communication. Right. So we will talk about synchronization now. Synchronization. Why do we need synchronization? Let's take an example here. So here in this example, we will discuss a scenario using threads where you would need the use of synchronization. So here we are going to see where you can use synchronization and what are the adverse effects if you don't use synchronization in such scenarios when using threads, right? So let's take an example where I have a banking application, right? And in this banking application, I do not post the account balances to the database every time somebody is making a transaction. So if somebody is making a deposit or withdrawal, I do not post the balances to the database at that particular point of time. But in fact, I maintain all the information in memory in the account object. So basically this account object represents an account, particular account, and whenever somebody performs some transaction, I'm simply updating the balance to this account object, and at the end of the day I'm going to post the balances to the database from this account object, right? So here in this example, I have the main method in which I create the instance of account, and this is for account 123, account with account ID 123, right? And I create two threads, T1 and T2, and I pass in the same instance of the account to both the threads, right? And I simply start the thread. So we know that two threads will be spawned for me when I start two thread T1 and T2, right? So this is the T1 stack and this is the T2 stack. And as we've learned earlier that when we talk about threads, you can perform multiple things at the same time. So both the T1 and T2 threads can process at the same time, right? So both T1 and T2's run method will be kicked off at the same time. And if you have take a note here, the account object, the account instance T1 and T2 has does refer to the same account object on the heap, because I am passing the same instance to both T1 and T2. So in a scenario where T1 is modifying the details of the account, T2 will also reflect the same details, and if T2 is modifying some details, the same information will be reflected in T1 as well, right? So let's take an example where I'm planning to withdraw some money from my bank account, right? And I realize that I do not have the ATM. I lost my ATM somewhere, ATM card somewhere. So what I do is I drive up to the bank, and I try and go to withdraw some money from the bank. Okay, and meanwhile, my wife, she realized that the ATM card is right there at home, and what she does is she doesn't inform me, and she again goes to the ATM center to withdraw some money from my bank account, right? So this is the withdraw method in the account class, and basically it's going to check if I have some balance on my account or not, and if only there is balance in my account, it's trying, it basically makes another check whether the amount I'm trying to withdraw AMT is greater than or equal to balance. So if the amount is greater than balance, it doesn't allow me to withdraw that money, right? So only if the amount is less than the balance amount, it's going to allow me. So you can add one more check there, and if the condition satisfies, it's going to give me back money, and it's going to perform certain related activities like updating certain flags and stuff like that, and in the end it's going to update the balance in the account class, right? So it's going to update the balance, saying that now the new balance is now my original balance minus the amount I have withdrawn, right? So let's say that I have $100 in my account left, right? And I go to the bank, and I see that I have $100, so I try to withdraw $90 from my bank, and at the same time, so that is T1, right? So when T1 enters the withdraw method, it is going to check if balance is greater than 0. Yes, it is. 100 is greater than 0, and it's also going to check whether the amount I'm trying to withdraw is greater than the balance, is less than the balance. So 90 is the amount I'm trying to withdraw, and it's less than the balance 100, right? So it's going to give me the money. So I get the money now. At the same time, my wife goes to the ATM center, right? And she checks the balance. So here in my T1 flow, the control has not come till a point where I'm updating the balance with the new balance, which is nothing but the amount which I have just withdrawn. So the actual balance now should be balance minus amount, that is nothing but 10. But since the T1 control has not come till this point, from T2 what I still see is the balance is 100, right? So when she sees the balance, it's going to be 100, and she tries to withdraw $50 from the account, and since the balance is being reflected as 100, it's not yet updated to 10. This condition still clearly satisfies. So balance is now still greater than 0, and the amount I'm trying to withdraw is still still less than the balance. So it gives her also the money. So at the end, what's going to happen is the actual balance was 100, but together we've tried to withdraw $140, and we have successfully withdrawn the money. And ultimately, after both T1 and T2 execute, at the end of the day, my balance would have been minus 40, right? Which should have gone into negative. And at the first place, I shouldn't have allowed this transaction itself, the second transaction itself, because I didn't have enough balance at that point of time in my account to withdraw, right? So this is a scenario where I'm having a shared object which is shared between multiple threads, and when multiple threads are trying to access the shared objects, it's going to modify the state of that object, right? So here in this scenario, my withdraw method should have been synchronized. And when I say that a method is synchronized, when a thread gets access to that method, to that object basically, no other thread can enter into that method. So once T1, so in my example earlier, once T1 enters the withdraw method which is synchronized, T2 will not be able to enter the method, withdraw method, unless T2 exits, unless T1 exits out of that method. So what will happen with the synchronized keyword in place is T1 is going to enter here, it's going to check if balance is greater than 0 and all this stuff happens, and till the time T1 exits the withdraw method, T2 will not be able to enter this. So when T2 enters the method, it's going to see that the new balance is 10 now and not 100, right? Because the balance is correctly updated since T1 has completely gone through all the statements in the withdraw method and exited out of the method. So once T1 exits out of the withdraw method, exits out of the synchronized methods, it again releases the lock, right? So when T1 enters the method, it has a lock and account. That means no other thread can access the synchronized methods of the account class, right? And once T1 exits out of the synchronized method, it again releases the lock. So at that point of time, T2 can access this account. So this is what synchronization is all about. If there is any common object which multiple threads are sharing, and you are concerned about the state of the thread, state of the object, basically the state of the shared object, you need to use synchronization wherever you are making such modifications. So wherever I'm using things like withdraw and deposit, I probably need to make my methods as synchronized. So let's say that in my account class, both my withdraw method and my deposit method were synchronized, right? So if T1 has an lock on the object, account object, it basically has a lock on all its synchronized methods, right? So even though T1 is currently executing withdraw method, all the other synchronized methods on this particular account object are also locked right now, and T2 cannot enter into any of the synchronized methods. So even though T1 is currently within the withdraw method, T2 cannot enter the deposit method as well, right? Because again, when you do a deposit, you are updating the balances, and when T1 here again is updating the balances. So we might have some inconsistencies there again. So basically when a particular thread has an lock on a particular object, it has lock on all the synchronized methods on that particular object, right? And so let's see if here we needed synchronization because I'm accessing the same account object in both T1 and T2, right? But if let's say that T1 was trying to access account 1 to 3 and T2 was trying to access account 3, 4, 5, let's say for example, then we wouldn't have required this synchronization in place because they are working on two different objects and they're not accessing the same object. So only when two threads have same object, a shared object, you would need synchronization on the methods, right? So basically the thread has a lock on all the synchronized methods of the object. So that's one. And the second thing is about the static methods. So there are two locks basically for each object. One is a lock on all the static methods and other is the lock on all the non-static methods. So you can have even synchronized static methods, and when a thread has a lock on the object on the static methods, no other threads can enter any of the synchronized static methods of that object, right? So this is a scenario where you would need synchronization on your shared objects, right?